A very good afternoon. This video has been recorded as a part of the assessment for CSEDU certificate program in computer science education given by IIIT Delhi along with the IIT Mandi. So in here, this is Dr. Vishnu from School of Computer Science and Engineering, Vellore Institute of Technology, Vellore. So here I'm providing explanation on the topic um, called unsupervised learning algorithms. Especially, I'm going to discuss about k-means k-means algorithm here. So k-means there are different types of unsupervised learning algorithms. K-means are clustering, agglomerative clustering. So along with the different types of case studies, I thought of explaining, but the time given is very less. So that's why I'm planning to explain the concept of k-means clustering in this class. So the presentation outline is given here. So introduction to machine learning. So what is machine learning and different types of machine learning algorithms, the categories of machine learning algorithms in so unsupervised category, k-means clustering and hierarchical clustering. So different types of case studies along with applications and summary I thought of discussing. So before that, I would like to give a brief insights on the different types of fields in computer science. So artificial intelligence and machine learning, which is a recently trending topic. So Internet of Things, virtual reality, blockchain, conversational systems, digital platforms, adaptive security architecture, digital health, big data analytics, and supercomputing. So finally, all these things will be analyzed through AI and ML algorithms. So AI and ML is suitable for a majority of the computer science fields. So, and not only computer science, it's applicable for various other fields as well. So the machine learning algorithms are basically classified into four types: supervised, unsupervised, reinforced learning, and the basic supervised, unsupervised I'm going to discuss here. So supervised is nothing but uh, we have to identify the patterns in the given set of features. So along with the features, we are going to be provided with the class labels as well. So just the machine learning model will be trained with the given set of features as well as class labels. Finally, we are going to give the another set of features without class labels. So the predicted values will be compared with the true values. So if the error is less, different types of evaluation metrics will be applied on that. So if error is less, and uh, we are going to try to minimize the error between the predicted values as well as actual values. So this is supervised. So another category is unsupervised. Here data will be given without any target attributes. So then we are going to cluster the data into two different kinds. So suppose if a set of students are given, so the students who are taller and who are shorter can be classified. So in case of unsupervised, because of their uh, characteristics. Similarly, in the class we can categorize males and females. So location of the person, geo mapping, so can be clustered. So latitude and longitude values are given. If so, these are the two categories. So unsupervised learning, the main important algorithms will come under clustering. So generally supervised uh, algorithms will be called as classification algorithms. So unsupervised clustering, so we are going to identify the groups in such a way that similar data will be placed in a particular group. Dissimilar data will be in another group. That means the group of people who are similar will be identified and placed. For suppose if I'm going to develop a recommender system, so then I have to identify a set of people who belong to a particular group. So that means who listen to sad songs, who listen to happy songs. So based on that one, I can divide and I can easily recommend what the relevant songs to them. So this is a so fine. The clustering is basically classified into two types. One is hard clustering and second one is soft clustering. So here hard clustering is nothing but, see, if I belong to one group means I'll belong to that particular group. So there is no connection with the other group when compared. That means if I'm listening to particular set of songs, I will listen always to the particular set of songs. So other songs I won't bother. But soft clustering is, so I belong to several groups. I have to identify which group is similar, which group is relevant to me. So fine. Generally, whenever we are implementing the clustering, so we'll take the measurement as distance. There are different types of distances: Euclidean distance, Manhattan distance, These are there are four different types of distances are there. So one thing, so whenever we are doing the clustering, one thing we have to keep it in mind in such a way that the distance between two different clusters should be maximized, and the distance of the data of that particular cluster should be minimized. So that is the main important. Suppose if you take the main simple example, so here the data, so this can be one cluster, and see this is, see here the problem is there are yeah, so here we are going to divide the data into these different clusters. So first, sorry, these are two different types of data. So in the first case, the SSC value is 6735. So second case SSC value is 5238. So the inertia value, how to calculate, I will explain. So fine. So here the main important thing is the sum of squared values or inertia value should be minimized. That is the main important thing. The formula to identify the inertia value is given here. So the distance between the data points of that particular cluster along with the centroid should be minimized. So SSC is equivalent to sigma j equal to 1 to k. We are going to identify the SSC value, sum of SSC values of all the clusters. So then where x belongs to Cj, the distance between x comma mj will be mj whole square will be identified. Here we are taking that uh, squared errors, because if there are negative data, then if it is squared, then it will be converted into positives. Generally we will take squared as errors. So fine. So now how to implement the clustering algorithm in case of k-means, I will explain it with a simple example. So take this as a point. Yeah, suppose if you are taking these two diagrams, you can easily understand the k-means process easily here. So here the data set has been taken in such a way that, so the annual income of a person is x-axis. That means loan amount against annual income has been plotted over here. So how much loan amount can be given based on the annual income. So this is the data. So here what I will do initially is I will identify three random points as clusters. So I'll plot them with red color. So here you can see there are three random points have been taken. Initially these three random points will be taken as a data points. Then what I will do is I'll identify the distance between this point to, I'll identify the distance. Similarly, I'll identify the distance from this point to this point. Yeah, if I had taken a point xi, then the distance between the c1 comma xi, the distance between the c2 comma xi, the distance between the c3 comma xi. So the centroid points as well as the distance to xi will be identified. Whichever the minimum distance, that will be considered. So that means c2, this point will be categorized as c2. Likewise, the same operation will be applied on all the x values. That means for I equal to 1 to n, we are going to similarly for j equal to 1 to k. That means k is a number of clusters, n is data points. So if it has been taken, then I'm going to identify the minimum distance between cj and xi. minimum of distance of Cj comma xi will be identified. Then that particular xi will be applicable to that particular Cj. So likewise we are going to implement this. Once this task is done, we are not going to stop the same, because we cannot decide that these random places. So initially these clusters have been placed in the random locations. Random points will be taken as a clusters. So once it is implemented, then what we are going to do is, whatever the labels given for xis with respect to Cj, so then we are going to take the mean of all those particular cluster values. Then the cluster will be replaced with the mean. So this process will be repeated till the clusters are uh, constant, or no, if there is no change in the clusters, we'll stop the process. That is a simple k-means algorithm that we can see here also. Just simple k-means algorithm. Yeah, we can see the same here. The same thing. Specify the number of k clusters. Randomly initialize k centroids. Repeat. So assign each point to its closest centroid based on the distance. Compute the new centroid by mean of this each cluster. So the centroid positions do not change. The same thing, whatever I explained is there in the algorithm. So if you want to see in detail algorithms, we can see that one as well. Yeah, here accept the number of clusters to group into the and the data set to the cluster as input values. Initialize first k clusters. Take first k instances of, or take random sampling of k elements. Calculate the arithmetic means of each cluster formed in the dataset. K-means assigns each record in the dataset to only one of the initial clusters. Each record is assigned to the nearest cluster using a distance measurement, example Euclidean distance or Manhattan's distance. And K-means reassigns each record in the dataset to the most similar cluster and recalculates the arithmetic mean of all the clusters in the dataset. So whatever I explained, the same thing has been given here also. So this is the process. And the same thing now after identifying, so we are going to calculate the SSC value. The SSC value should be minimum. So the SSC value will be deciding the cluster values. So initially we will take first cluster. That means one thing here, we cannot keep only single cluster. There is no meaning. At the same time, each data point cannot be assigned to a different clusters. That means the cluster value should not be 0. Sorry, k value neither should be 1, or k should not be equivalent to n. So both are meaningless. So what we are going to do is, we are identifying the suitable k. The suitable k value will be identified by calculating the SSC values. So with all these things, I had written some code here. I'm going to explain the process of code. See, I have included a k-means class, k-means class, which is available in the sklearn.cluster. So the package has been imported. Scikit-learn is a package which is having all the uh, classification tools and clustering tools. So PD I have taken pandas attribute, and numpy is for NP to plot the data PLT, which is a matplotlib.pyplot. So I had taken the wholesale customers data, so downloaded from the internet, which is having different fields: channel, region, fresh, milk, grocery, frozen, detergents, paper, and delicatessen. Delicatessen. Sorry. So data dot describe. So the data set values, the total number of values, mean, standard deviation, everything has been plotted over. So then what I had done is, I had scaled the data to -1 to 1. So you can see the data will be scaled here by using the standard scaler. So standard scaler will take care of this scalar dot fit transform of data. So data scaled is the main attribute. So fine. Now for the data scale, I have applied the k-means algorithm here. So previously I had done the same thing for uh, annual income over loan amount. So by using 3 clusters. So this way I separated. Now I'm going to explain what is the necessity of SSC here. So k-means class I had called with, initially I'm assuming that 2 clusters. So initialization with k-means plus plus. So I'm specifying that. So data scale has been fit. So then I have calculated the inertia value, sum of squared value errors. So that inertia value is 2599.38. So I want to know whether two clusters are fine or not. So then what I had done is I had taken the SSE list. So with empty, then I had taken the cluster ranges from 1 to 20. I thought of creating 20 clusters here. So then for each n clusters equal to cluster, I have fitted the data. So then I have added the inertia value to the SSG. So then cluster 1 to ray 1 to 20 I have created. Cluster is a one column, and SSC values have been created as a second column, and I created the data frame. Then frame of cluster x-axis has been plotted as cluster values, and y-axis has been plotted as SSC values, and marker I had given circle. So number of clusters and inertia will be the x and y axis here. So if you see the first cluster, the SSC value is more than 3,500. Second case with the two clusters, the SSC value is 2,600. With the three clusters, the SSC value is 2,300. Four clusters, SSC value is 2,000, around 2,000 odd. Five clusters, 1,500. Likewise, whenever there are 20 clusters, the SSC value is around 520 or 500. So, but creating. So suppose if you take this image, copy image. Yeah, in this case, so creating one cluster for all the data useless. So we cannot see. Suppose if I have 1,000 movies, I want to keep them as single folder. Then it is very difficult to search for the data. Then similarly, if I keep them as 1,000 folders, then also it is useless. So I have to identify where the SSA value is getting. That means average SSA value has been taken here. Seven is 7, 8, 9 can be taken as a cluster. So with the 7 I have experimented again. So k means clusters of 7. Then I have plotted this. I have applied on data scale on the scene. Then k means dot predict data scale. So then once it is done, so first cluster is having 191 values. Second cluster is having 101 values. Third cluster is sorry, zeroth cluster is having 88 values. Third cluster is having 32. Sixth cluster is having 22, and second cluster is having 5, and fourth cluster is having 1. The total number of data samples I will plot if you want. Data dot shape. So there are 440 values. So I can find the frame of cluster dot value underscore counts dot sum. So 440 is the data. So this way the data has been classified into different types of things. Here we have discussed about what is clustering and how k-means can do the same clustering process. While doing that, we have to decide how many clusters. The decision of clusters can be taken by using the inertia value, and at the same time the inertia value, once it is plotted, then inertia value will the k values as inertia values will give a clue to identify the number of clusters, suitable number of clusters. So finally this way we can implement the k-means algorithm. So likewise we can the advantages of k-means algorithm have been given here. So the time complexity is tkn and simple and efficient algorithm. So it is having the drawbacks as well. If the data is sensitive to the outliers is nothing but, suppose if you are if you are collecting the information, if suppose if average age of the people who do cycling is 25 to 30 years, suppose if any some people are there who even if they are 70 years they will do the cycling, so then they will be called as outliers. So the outliers data, if it is there, then k-means will not work properly. Then in that case we can go for the another hierarchical clustering. That is another hierarchical clustering will be the another one which will be used to draw the dendrograms. The dendrograms will be helpful to cluster the data. So fine. So this is about the k-means algorithm. So and so thanks for the effective teaching given by CSEDU program. So I'm very happy to attend those sessions, even though because of my timetable, I was unable to attend regularly, but I used to watch all the videos. So they are very important, and so they made me to learn machine learning in proper way and how to explain the same in class environment they had taught in beautiful way. And especially if you discuss about Mitesh Kapra sir, how he explained this algorithm is K-means is really good. So thank you for all the support.